Hi everybody, welcome to the channel. In this video we're going to take a look at a couple examples dealing with the area between two curves, and both of these examples are going to be a little bit more unique or a little bit more special cases. And so in the first one we're going to take a look at an example where both of the functions cross on the interval that we're talking about. And then in the second example we're actually going to see an example where it might be helpful to integrate not with respect to x but rather with respect to y, and we'll see why might we want to do that, and when is it helpful to have that situation. So let's take a look at the first example. We want to find the area between two curves. So let's say find the area between, I'm going to use y equals the sine of x and y equals the cosine of x. And specifically we're going to be talking about on the interval from 0 up to pi over 2. Now, I might think about what these graphs look like. From 0 to pi over 2, the sine graph is supposed to start at the origin and go up and kind of have a maximum there at pi over 2, and then it starts coming back down. And the cosine graph is supposed to start up at 1 and it's supposed to go down and cross the x-axis at pi over 2, and then it keeps going down from there. And so when we're talking about the area between these two graphs, we're talking about finding that area right there and that area right there all the way up to pi over 2. And something I said in the last video is that you might want to consider graphing these on your calculator and setting your x minimum to be the a value and your x maximum to be the b value, so you can see this in a good window. Now what we want to do before we just jump in and try to find an integral is we want to see, do these functions cross somewhere? Okay, by the way, some of the examples that you're going to have, some of them do cross, some of them don't. You can't just assume that. You don't necessarily know. And remember, we can't just find the integral from 0 to pi over 2 of one function minus the other. If they do cross, we actually have to split this up. And we have to find where they cross. And these two, clearly, based on the graphs, they do cross somewhere. And so the question is, where is the sine of x equal to the cosine of x? Okay, well, this shouldn't be too bad. If you remember from your trig, sine of x is equal to root 2 over 2 at pi over 4, and so is the cosine of x. So this place right here, this angle, is supposed to be pi over 4 where they cross. So what we want to do then to find the area between these two is we actually need to split this up into two separate integrals. It needs to be the integral from 0 to pi over 4 of something, and that something is going to be one function minus the other one. And then we also need a second integral, the integral from pi over 4 up to pi over 2, and again, one function minus another, dx on the end. And so the question is, well, which function goes on top, or is on top, and which function's on the bottom? Which one do we subtract from which? And so if you look at the cosine graph that starts out high at the beginning, the cosine graph is above the sine graph. So for the first half there, we're going to have the cosine of x minus the sine of x. And then for the second half, the sine graph is above the cosine graph, and so we're going to have sine of x minus a cosine of x. Now at this point, this is really not much different than what we've done in the last few videos and the last few sections. The only kind of new part here was that we had to find out where these two cross and look at how to set up the integral. But then the integral is exactly the same as we've always been doing. Now these are both definite integrals, but that's okay. We can handle both of these, and then we can find a number. Keep in mind that with definite integrals, we're finding a number as our answer. We should find a number for both of these, then add that number together. In fact, I think you get the same thing in either region there, and you're going to actually end up having double of whatever number you get on the inside there. But let's check it out. So we have something like the integral from 0 to pi over 4 of the cosine of x minus the sine of x dx. And so go ahead and integrate here. When you integrate a cosine of x, you get a sine of x. And when you integrate a sine of x, or I should say a negative sine of x, you actually get a positive cosine of x. Remember, you can always check those antiderivatives by taking the derivative of what you get and saying, did I get what I started with? Okay, so this is evaluated from x equals 0 up to pi over 4. And let's see, we should be, let's go ahead and just look at this one first, and then we'll look at the second one. So this is the sine of pi over 4 plus the cosine of pi over 4 minus, now be careful again, parentheses there, the sine of 0 plus the cosine of 0. So be careful here. Remember, sine of pi over 4 and cosine of pi over 4 both give you the same thing. They give you root 2 over 2. So root 2 over 2 plus root 2 over 2. And then let's see on the inside, minus the sine of 0 is 0. And then the cosine of 0 is 1. So this is what we would get for our first integral there. Let's see. If you add these two together, this would be 2 square root of 2 over 2 minus 1. That's something like root 2 minus 1. But remember, this is only for the first part, only for the first half. Now, and you can go ahead and take a second and do this on your own. I think if you do this second part here as well, and you take the antiderivative and you plug those in as well, I think you get exactly the same thing. Okay, let's go ahead and check that one as well. So the integral from, do that on this next page here, the integral from pi over 4 to pi over 2 of sine of x minus the cosine of x dx. Let's see, when you take the integral here, this should be minus a cosine of x, and then minus a sine of x, and this is all from pi over 4 up to pi over 2. So minus cosine of pi over 2 minus the sine of pi over 2, and then that's all minus, keep in mind parentheses there, so it becomes minus the cosine of pi over 4 minus the sine of pi over 4. And so, let's see, the cosine of pi over 2 is 0. The sine of pi over 2 is 1, so it becomes a minus 1. And then over here we have minus, when you combine these two together, it gives you a minus square root of 2 minus square root of 2. There's a lot of negatives in here, so minus root 2 over 2 minus root 2 over 2. And notice in here you end up getting something like negative 1, and then in here it would be a minus 2 root 2 over 2, and then you actually have a negative of that, so really a plus root 2. Now you might say, well, if you look at this, this is exactly the same thing as what we had, a root 2 minus 1. And as I suspected, we get the same thing in both cases. So another way to think about your answer says take whatever you got here and add that to itself. So just double that. And so our final answer gives us something like 2 times the square root of 2 minus 1, or 2 root 2 minus 2. Okay. So we do need to be careful about where our graphs intersect. If they intersect in our interval there, then we need to split it up into multiple different integrals, and we need to find that point where those two graphs cross. Let's take a look at one last example. And in this example, we're going to use two different graphs that are actually not functions. So that's okay. We've seen in a lot of classes, including in a pre-calculus class, that we don't need to always be talking about functions. So we're going to have something that starts out like this. X equals y squared minus 4x. Or I'm sorry, minus 4, so used to writing functions, minus 4y. And then the other one is going to look something like x equals 2y minus y squared. Okay. You may remember these as parabolas that don't open up or down. One of them opens left and one of them opens right. So the graph actually looks a little something like this, where one of them goes like this. They definitely both go through the origin. Here. And despite my poor drawing of a graph, this point up here, I'll give you that point right there. That point is supposed to be the point negative 3, 3. Now I haven't put any scaling on this graph, but it doesn't necessarily look like it's similar scaling in the x-coordinate as or in the x direction as it is in the y direction. Sorry about that, but you get the idea here. And we're trying to find the area between these two curves right there. All right. Now, here's the problem with this, is if we split it up in terms of x's, and looked at where they crossed. Let's say we were talking about kind of A there and B there. We'd have to find one point where they intersect, another point down here at x equals 0 where they intersect, and we'd actually have to split this up into 3 different intervals, into 3 different integrals, which would not be easy. Okay, I think instead of splitting it up into 3 different integrals and trying to integrate with respect to x, meaning having a dx on the end, it's probably a little bit easier to think about it something like this. Think about it as the integral from y equals 0 to y equals 3, because that's the y coordinate of that top point where they intersect. And now instead of integrating with respect to x, we're going to integrate with respect to y. Now if you have a dy in here and you have y as your bounds, then you're not going to have x's as your kind of argument in your integral here. You're going to have y's. Now the question is, which one are you going to have first? Are you going to put y squared minus 4y first, or are you going to put that one second? Well, I hope what you've kind of taken away from some of the others is it actually doesn't really matter, as long as you go ahead and take your end answer there and use an absolute value on the end. So I'm going to write it like this: y squared minus 4y, and then subtract the other, well, I was going to say a function, subtract the other expression there, 2y minus y squared, and then you can subtract and integrate in the same way that you did before. It's just instead of having x's, now we're going to have y's. Okay, I think it's easier to probably clean this up first before you think about trying to integrate. So let's clean it up a bit. So this is from y equals 0 to y equals 3. And let's see. We have a y squared, and then we're going to have a minus a negative y squared. You got to make sure you distribute that negative in there. So it's going to be a y squared plus a y squared. So we're going to have 2y squared, and then we have a negative 4y minus 2y, so negative 6y dy on the end. Okay. Now this isn't too bad to be able to integrate. It's just a little weird thinking about it with y's instead of x's. So I'm going to move to the next page. 2y squared minus 6y, and this is dy. Remember, y is going from 0 up to 3. Okay, so go ahead and integrate. Let's see, this should be a y to the third, so we need a 2, and then we're going to need a 1/3 in the front, so it ends up being a 2/3. And then this ends up being a y squared, so we need 6 divided by 2, so we need a 3 in the front. And we are going from y equals 0 to y equals 3. Okay. Now it's always nice when 0 is one of your bounds, especially when you have polynomials here. Not too bad, because when you plug in y equals 0, you just get 0 for the whole thing. So this is really 2/3 times 3 to the third minus 3 times 3 squared, and then really just minus 0, because when you plug in 0 everywhere, you just get 0. So, okay, let's see, 3 to the third is 27. You're going to have a divided by 3 on the bottom, so you're going to have 9. So 2 times 9 is 18, and then 3 squared is 9 times 9, 9 times 3 is 27. 18 minus 27. Okay, I got minus 9. What does that mean again? Oh yeah, it means I did it in the wrong order. I probably should have done it the other way around, but go ahead and take the absolute value. That means you should be getting 9 as the area there between the two curves. Okay, so again, they didn't really cross as far as going from y equals 0 to y equals 3. They did cross if you take an integral with respect to x, but if you take it with respect to y, you're fine there. I just needed to be careful to not have a negative area, because that doesn't make any sense when we're talking about the area between two curves. Take the absolute value and get 9. Okay. Hope these examples helped. Again, these are kind of unique examples that we could have where our graphs either cross or where we need to take an integral with respect to y instead of x. All right. Hope you're getting a lot of practice. Just like with taking derivatives, these integrals take a lot of practice. So just do these over and over and over again. Think about what kinds of integrals you need to be able to use. Practice, practice, practice. All right. Hope the video helps. Enjoy.